My name's Jo. Welcome to the Confusion Matrix. So, I'm a chemist, not a biologist or an ecologist, but since my PhD project has been a combination of chemistry and biology, a lot of the time that I've spent reading biology textbooks and papers has looked a little something like this. The full FASTA file was demultiplexed and adapter trimmed and subsequently filtered to remove any terminal regions with a PHRED quality score less than 20. Wikipedia. So allow me to present my Guide to Coral Biology and Physiology as presented hopefully correctly by an analytical chemist. What are you saying? Ugh. What could possibly go wrong? So in my last video, which admittedly I did post an awfully long time ago, I mentioned that there were about 350 species of hard corals. Now, we're going to focus primarily on these scleractinian or hard corals because they literally form the backbone of the reef. These corals are actually made up of two completely different organisms living in symbiosis, which is really just a fancy word for partnership. So there's the coral animal itself, and then living inside the coral are these microscopic algae known as zooxanthellae. This amazing picture from archive.org is a close-up of a coral polyp. The zooxanthellae actually live inside a layer of tissue known as the gastrodermis, and they're the brown spots that you can see in the photo. Now, zooxanthellae are the reason that corals can live in nutrient-poor waters. You see, corals are what's known as polytrophic, which means they're both heterotrophic, meaning they eat food just like us, and autotrophic, which means that they're photosynthetic. Because there's so little nutrients in the waters surrounding the corals, they cannot solely rely on heterotrophic feeding. And so the zooxanthellae, in exchange for shelter and protection, transform sunlight into food for itself and its host. Now, if you've been keeping an ear to the ground, you'll be aware that there is something extremely very not good happening on reef systems around the world. Something is making corals go from this to this. So what's going on? Well, under certain conditions, the symbiotic partnership between the coral host and the algae completely breaks down. External environmental changes, known as abiotic factors, can completely mess with the reef in a variety of creative ways. These include things like increases in temperature, changes in salinity, changes in light intensity, bacterial infections and various diseases, ocean acidification, decreases in temperature, and eutrophication, which is an increase in nutrients in the water due to land runoff, and this one is in some contention. Wait, what? You heard me. Damn it. All of these abiotic factors in combination or by themselves can cause coral bleaching. This happens when the zooxanthellae pack up and leave. This means the coral loses its colour and turns white, hence bleaching. Wait, so you mean it's not... Oh, good grief, no! Unfortunately, the corals don't just lose the thing that makes them pretty, but also up to 90% of their organic carbon requirements. And when you remember that corals live in the ocean's equivalent of the Sahara Desert, losing their primary food source is not super fantastic. If the environment does go back to the way it was, the corals do have a chance to get their symbionts back. But if this doesn't happen fast enough, we end up with what scientists call mass bleaching events, which is where giant sections of the reef die. But the big question here is, are all species of scleractinian coral affected? The answer to that question is no, which then brings up another question.